We have been learning how to solve quadratic equations. In other words, how to determine the value of x when y equals 0. And we said when b is 0, the best way to solve is by finding square roots. But then we said if b is not 0, sometimes you can solve by factoring. But now what do you do if you have a quadratic equation that cannot be factored, or it cannot be easily factored because the numbers are so large? Then you have to solve by using the quadratic formula, and that's what we're going to learn about today. This is the quadratic formula, and you do need to memorize this. And I have a song which I will teach you when we meet, which will help you memorize this, but I am not going to sing the song on the video. But I do have a song which I will sing to you, and it will help you memorize this. Now, when you are in Algebra 2, you will learn more about where this came from. But right now, you just need to memorize it. And right now, you just need to know this is used to solve quadratic equations when the equation cannot be factored or it cannot be easily factored because the numbers are very large. Then we're going to talk about the discriminant. The discriminant is what is underneath the radical symbol, and the discriminant is going to tell us how many real solutions the equation has. Now, it's not going to tell us what the solutions are. It's just going to tell us how many there are. So, in other words, the discriminant is going to tell us how many times this graph is going to cross over or touch the x-axis, if at all. So look at example number 1. We are going to solve using the quadratic formula, and I want you to work this out with me. Pause the video along the way and work this out with me. The first thing I have to do is set this equation equal to 0. You have to put the equation in standard form and set it equal to 0. Then you have to identify what is your A, what is your B, and what is your C. Then you take A, B, and C and you plug it into the quadratic formula. So that's what I did. I took my A, my B, and my C. I took the values for A, B, and C and I plugged it into the quadratic formula. And now at this point, all I'm going to do is simplify. The biggest mistake people make when simplifying quadratic formula is order of operations. Right here. Remember what order of operations says. Order of operations says you have to multiply before you do any addition. And so this is the biggest mistake students make. You have to take -4 times -8 first before you do any addition underneath the radical symbol. But once I do that, then I just continue simplifying. Again, work this out with me. The square root of 36 is 6. Now notice here at the end, I have 2 plus or minus 6 divided by 2. That means I need to solve both ways. I need to figure out what is 2 plus 6 divided by 2, and I need to figure out what is 2 minus 6 divided by 2. So here are my two solutions. These are the two values of x when y equals 0. In other words, the graph is going to cross over the x-axis at 4 and -2. So that's the basic process, and the process does not change from one problem to the next. There's nothing tricky about this. The only time a problem can get more complicated is right here. If this is not a perfect square, if this does not come out to be a whole number, you have to simplify the radical. And that's what we were doing in the last chapter. And that's actually why we did chapter 10 before we did chapter 9. If you end up at this place right here, and this is not a perfect square, if it does not come out to be a whole number, you have to go through the process of simplifying the radical and then reducing the entire fraction. Now the book does not ask you to do that. The book says just take your calculator and figure out what it is as a decimal. But we're not going to do that because that's not how it's going to be on your SAT, and that's certainly not how you're going to do it in Algebra 2 and in college algebra. So again, if you get to this point right here and it doesn't come out to be a whole number, you need to go through the process of simplifying the radical and then reducing the entire fraction at the end. And if you're doing your homework and you have any questions on that process, please email me. Now go ahead and hit pause and work out this on your own problem by yourself and solve using the quadratic formula. Let me walk you through what I did. I took the equation and I put it in standard form and set it equal to 0. I then identified what my a, b, and c is, and then I plugged that into the formula. This is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And here a is 1. And then be careful because of your order of operations. I need to do my multiplication first, then I can do my addition. And then remember, at the very end, I have to figure out what is 4 plus 10 divided by 2 and what is 4 minus 10 divided by 2. And finally, we are going to talk about the discriminant. Remember, this is the discriminant and it is what is underneath the radical symbol. And it is going to tell us how many real number solutions the function has. So this is what you need to write down and you need to memorize. But it makes sense if you think about it. So if the discriminant is positive, you will have two real solutions. For example, if the discriminant ends up being 100, you have negative b plus or minus 10 all over 2a. So you will have two real solutions. This is what we did in example number 1. So anytime the discriminant is positive, you will have two real solutions. But what happens if the discriminant is negative? That means you will have no real solutions. Now the reason why we say real solutions is because in Algebra 2 you will learn about imaginary solutions, but we're not going to talk about that right now in Algebra 1. All you need to know right now is if the discriminant is negative, there are no real solutions. This means the graph does not cross over or touch the x-axis at any place. There's no value of x that will set this equation equal to 0. There's no real value for x that will set this equation equal to 0. And again, it makes sense if you think about it. If the discriminant is negative, that means we have the square root of a negative number. And can you take the square root of a negative number and end up with a real solution? And the answer is no. And finally, if the discriminant is 0, you will have one real solution. And this is why. If the discriminant is 0, you have the square root of 0, which is 0. And so what is your solution going to be? X equals negative b over 2a. And you should recognize this. What is this? Remember, that is how we determine the x coordinate of the vertex. So if the discriminant is 0, you will have one real solution. So now what I want you to do is go back up here to this example and determine how many real number solutions does this function have. And the answer is no real solution. Because the discriminant is negative, this equation has no real solution. And finally, this on your own problem is on the next page. Go ahead and hit pause and work out this problem. Determine how many real solutions this equation has. Because the discriminant is positive, this equation is going to have two real solutions.